Hi to all. Today we are going to discuss the fringe width in Young's double slit experiment. Fringe width is also called as the bandwidth. This is very important topic for the 3 marks or the 5 marks. Based on this, in the board exam, either you will get the problem or the theory. Let us go for this. What is the fringe width or the bandwidth? The distance between the distance between distance between successive the distance between successive bright bands distance between the successive bright bands are dark bands. The distance between the successive bright bands are the dark bands is called as fringe width. Is called as the fringe width. The definition of the fringe width. Fringe width is also called as bandwidth. It is denoted with is denoted by beta. Okay, the fringe width is also called as bandwidth. Fringe width is also called as bandwidth. Okay, now how to derive the fringe width formula? What is actually fringe width? See this. For example, this is a bright band. Okay, and next this is a dark band, and this is a bright band. Like this, in the interference, you will get the bright and dark bands. You know that one, right? In the interference, you will get the bright and dark bands. If it is the bright band and it is the dark band, it is the bright band, it is the dark band, bright band. Like this, here for example, this is the first bright band. Any one bright band center this one. This is the next bright band. The distance between these two successive bright bands, the distance between the successive bright bands is called as the fringe width. Fringe width is the distance between two successive bright bands, or it may be taken as it is the distance between the two successive dark bands also. You may take like this. This is the dark band and this is the dark band. The distance between the two dark bands is also called as the fringe width. Fringe width is the distance between successive bright bands or the successive dark bands. Okay. Then let us see how the bright and dark bands will be forms. And I want to know the distance of some nth bright band or fringe width formula I am going to derive. Then for the purpose, I will draw the diagram it here. Let us see here. S1, S2 are the two slits and S is the source and this is the screen. And from S source the light will started and this is the center of the screen you see. O is the center of the screen. And D is the separation between the two slits. Separation between the two slits is D. Okay. And the distance of this, these are the slits, two slits. S is the source. S is the source. Okay. And now the light is starting from S1 and that will pass us to some point Light started from S1 and it reaches at some point P. Light also starts from S2 and it is also reaches the same point. You see here the light started from S1 and S2. Okay, and they are meeting at point P. They are meeting at point P. At the point P, you may get the bright or dark band based on the superposition. Okay, and this is some band at here you will get. This is either bright or the dark band. The distance of this band we can take it as from the center of the screen we can take as y. Okay, and now in this we write some terms at here. What is S? S is the source and S1, S2 are the slits. O is the center of screen. Center of screen. What is D at here? Small d is the separation between gap between two slits. Separation between two slits. What is capital D at here? You see the capital D is this one. Capital D in the figure is distance of distance of screen from the slits from the slits. Y is what? Y is the distance of bright or dark band, whatever it may be. We don't know whether it will forms bright or dark. It is the distance of bright or dark band from the center of screen. From the center of screen. Okay. Now you take the screenshot and note it. I am going to erase. Before erasing, I will tell some more information at here. The width of the slit is d at here. I will write here one line at here like this in the black line I will draw. Otherwise, any other color I will use. You see this. What is this distance? This distance is the d by 2, right? And this is also d by 2. Why it is d by 2 and d by 2? Because we know the separation between the two slits is d, and this is the half, right? And this is the remaining half. D by 2, d by 2. If you will add this d by 2 and this d by 2, we will get the d. D is the separation between the two slits. D is the separation between the two slits. This is totally d, and this half is d by 2 and this is also d by 2. I want to know one thing, that what I am going to derive, I am going to derive the fringe width formula. For that, it is the distance between the two successive bright bands or the two successive dark bands is the fringe width. For that, what we have to do it here, just you see here, we have to find out the path difference it here, path difference between the two light waves, and write the condition for the bright band. I want to find out the distance of bright band in nth bright band from the center of the screen. Okay, I'm going to erase this. You take the screenshot and note it. I'm going to erase manually on the left side. What is the path difference between the two light waves on reaching the point P? Path difference between two light waves on reaching point P. From figure, what is the distance traveled by the first light wave? You see the figure very carefully. Distance traveled by the first light wave is S1P. This we will take as P. You see this. This is the P. Distance traveled by the first light wave is S12P. Distance traveled by the second light wave is S22P. That means here you see that the path difference is S2P minus S1P. Okay, that we can consider as delta X. But from figure we write one thing. From figure we find out the S2P square. What you will get, S2P square minus S1P square I want to find out. Okay, I want to find out S2P whole square minus S1P whole square. S2P is what from the figure? You see very carefully, S2P is this one. You take one triangulate here, you see. Okay, and from this triangle, okay, if you take this as this point, I will take as A. This point I will take as B. You take one triangle that is S2PA triangle. S2PA triangle you take. From this triangle, S2P square equal to S1 S2A square plus AP square we write. It's a rectangle triangle. You see very carefully, it is a rectangle triangle. In that S2P square equal to we write is S1 S2A square plus AP square we write. Okay, we write as from the figure S2A square plus AP square we write minus, and you see one more triangle that is S1P I want. You take this triangle S1PB triangle. From that it is also rectangle triangle. We write S1A square plus BP square we write. From where we are writing these two? These we are writing from triangle S2AP comma triangle S1BP triangle. From these two triangles we are writing this one. Okay, right. And now we have to simplify this. S2A is what? It is a D from the figure. D square plus AP is what? AP you see OP plus OA we write. OP is Y. OA we write that is equal to D by 2. We write it as AP as Y plus D by 2 whole square we write. AP is Y plus D by 2 minus S1A. S1A is what? S1A is, this is not S1A. S1P is S1 into B, it is B, not A. Okay, S1B is again D square plus BP is what? BP means this part, B2P. That is OP minus OB we write. From this total OP, you subtract the OB. Then we will get as Y minus D by 2 whole square. Y minus D by 2 whole square we write. Okay, now we have to simplify this. The D square plus, this we write as A plus B whole square formula. Y square plus D square by 4 plus 2 into Y into D by 2 minus. This also you apply the A plus B whole square formula. If you apply A plus B whole square formula, D square, right, plus here A minus B whole square formula we have to apply. Y square plus D square by 4 minus 2 into y into d by 2 we write. Now we have to simplify it. When you will simplify this, almost most of the terms will be cancelled. This d square will cancel. y square, y square will cancel. D square by 4, d square by 4 will cancel. What's remaining it here? Here it is remain 2 yd by 2. 2 gets cancelled, then yd will remains. Plus, this is the minus into minus plus you will get plus yd. Then finally we will get as 2yd, right? Then from this, we write like this. I'm going to erase the right side. Continuation I am going to explain, that is s2p square minus s1p square. We got as 2yd. And this we write as a minus b whole square formula. We write as s2p minus s1p into s2p plus s1p we write. That is equal to 2yd. What is s2p plus s1p from the figure? If small d, distance between the two slits, is less than capital D, and small y is also less than capital D, then we write s2p plus s1p nearly equal to capital D plus capital D. That is equal to, we write as 2D. Okay, this we substitute in above equation. Then we will get s2p minus s1p into, we write as 2 capital D is equal to, we will get as 2yd. At last we will get the path difference, s2p minus s1p. It is a path difference. It is 2y into small d by 2 capital D. This 2 gets cancelled. Finally, we are getting the path difference formula. Yes, the path difference is equal to delta x, that is equal to s2p minus s1p. That is equal to, we write as y into small d by capital D. This is equation 2. We got the path difference formula from equation 2. Next, I am going to erase and I will continue. Okay, let us go for the next point. There is a condition for breadband. What is the condition for breadband? Condition for breadband. You know that the condition for the breadband, that is delta x is equal to path difference is equal to path difference delta x is equal to n lambda. But what you got the path difference at here? N value is 0, 1, 2, 3 and so on. Now I am going to explain the condition for the breadband. There is a condition for breadband is the path difference equal to delta x equal to n lambda, that we know previously, where n is equal to 0, 1, 2, 3 and so on. And here delta x formula we write from equation 2 as y is into small d by capital D we write. But here I want the y formula. Here y is equal, we will get is n lambda into capital D by small d. And here what this y indicates? Y indicates the distance of certain bright or dark band from the center of the screen. And this is you can consider as equation 3. Here the y indicates the distance of nth bright band from center of screen. From center of screen. Now, if you write n is equal to 1, then you will get the distance of first breadband. What is the distance of first breadband? First breadband distance is y1 is equal, we will get is n you substitute n in equation 3, n you substitute as 1, then we will get as lambda d by d. If you substitute n is equal to 2, if you substitute n is equal to 2, distance of second breadband you will get. Distance of second breadband from center of screen. That is y2 is equal, we will get as 2 lambda d by d we will get. I want the fringe width. Fringe width is nothing but distance between the successive breadbands. This fringe width you will get by subtracting the distance of first breadband from second breadband. You see, let simply I will give, this is the breadband. This is the breadband. It is the dark band we can consider. Next it is the bright band. It is the dark band. It is the bright band. You see here. Okay. What is this? This is the bright first one. That also with the on both sides bright and dark bands will be there. Listen very carefully. This is the 0th bright band, right? 0th bright band. And this is the first bright band. First bright band. This is the second bright band. Okay. Here we write this as the first bright band below bright n is equal to -1. This is n is equal to -2. Next bright band. These are all bright bands. Now the distance of the first bright band from the figure, the first bright band from the center of the screen. This is only center of the screen. N is equal to 0 is the center. We take it as the center. Okay, we take it as the center. This is the O. Okay, from the distance of the first bright band is y1. Distance of the second bright band from the center of the screen is y2. Okay, if you find the separation between these two bands, okay, when you will do the y2 minus y1, you will get this one. This is nothing but distance between the successive bright bands. That is the, you see here. Again, I will explain this is the center of the screen. First breadband distance is y1 from here to here. Second breadband distance from the center of the screen is y2. If you subtract them, you will get the distance between the successive breadbands. Okay, from here to here, you will get that is the y2 minus y1 is the beta. Then we subtract and we find out the beta formula. That is 2 lambda capital D minus lambda capital D by D. Finally, we will get the beta formula, that is lambda capital D by small d. This is the formula for the fringe width. That is based on the condition for bright band. Based on condition for dark band also we can derive. Condition for dark band is what? Yes, we know already condition for dark band. This is equation 4 at here. Condition for dark band. What is the condition for the dark band? That is the path difference delta x is equal to path difference delta x is equal to, we should get, we have to get n minus 1 by 2 into lambda. Okay, we have to substitute here as n is equal to 1, 2, 3 and so on, not from 0, right? Then we have to write it here delta x as, we know from equation 2 delta x we write as y into small d by capital D is equal to n minus 1 into lambda. This is from equation 2. Okay, and the next I'm going to erase, and you take the screen. Continuation we will discuss, that is y into previous equation is what, y into small d by capital D is equal to, we got as, oh, n minus 1 by 2 into lambda. From that y formula I want to derive, we will get like this, n minus 1 by 2 into lambda capital D by small d. We will get, this is the equation. Previous equation is 4 na? Then this is equation is 5. And what y indicates at here, y is the distance of nth dark band from center of screen. If n is equal to 1, you substitute, you will get the distance of first dark band from center of screen. Distance of first dark band, that is y1 is equal to, we will get is, n you substitute 1 at here, then simplify it, you will get to 1 minus 1 by 2 into lambda capital D by small d. Finally, we will get lambda capital D by 2d. We will get, this is equal. No need to give any equation. And if n is equal to 2, you substitute, you will get the distance of second dark band. What is the distance of second dark band from center of screen? You substitute. N is equal to 2, you should substitute. Then finally, we will get 3 lambda capital D by 2d. We will get. I want the fringe width. Fringe width is what? Fringe width are the bandwidth. It is the distance between the successive bright bands or the dark bands. I want to find out the distance between the first and second dark bands. That is y2 minus y1. You substitute in 3 lambda capital D by 2d minus lambda t by 2d. If you simplify this, 2 lambda capital D by 2d we will get. Finally, beta formula we will get is lambda capital D by small d. Okay, that means from this is considered as equation 6. From equation 4 and equation 6, distance between the successive dark bands or the successive bright bands is the same. Okay, that is the fringe width. The fringe width final formula what you got here, right? Fringe width or the bandwidth. Beta is equal to, we will get as lambda capital D by small d. On what factors the fringe width depends? The fringe width depends upon wavelength. Fringe width depends upon distance of the screen from slit. Fringe width depends upon the distance between the two slits. On these three factors, the fringe width depends. Okay. Thank you for watching my lectures.